everyone, this is Mrs. Snowbeck. Today we are going to do Unit 7, Lesson 3, and actually I would cross out this title and I would change it to Arc Lengths. That's going to be our focus today. So when you think about a circle, like yesterday or last time we talked about if you have a central angle, and let's say your central angle is 80 degrees, well, this arc also has a measure of 80 degrees. This angle and this arc have the same measure. But what if you wanted to figure out like how many inches that arc was? Well, you wouldn't say it's 80 degrees inches. You'd have to figure out in inches how long that was. Like if you were building like a bird bath and you wanted to go buy some plastic to form around the outside of the circle of the bird bath, you wouldn't go into Home Depot and say, I want 80 degrees of that plastic. You'd go in and say, I want 40 inches of that plastic or whatnot. So there is a formula for finding arc length, and it goes like this. It's cursive L, I guess that stands for length, equals x over 360 2 pi r. And the r stands for radius. And remember, you can tell from your picture here that the radius is halfway across the circle. A second way that you could write this is you could say x over 360 pi times diameter, because 2 radii is the same as a diameter. So both of these work. I tend to use this top one more often. So number 1, part A, find the length of arc ZY. Notice the little curve above the ZY, that means arc ZY. And so if we want to do that, we're going to use our formula. L equals x over 360 2 pi r. So the x is going to be the degrees. So we're trying to find the length of arc ZY. That's this arc right here. We want to figure out how many inches is that arc. And so for x, we're going to put in the 75. So it's going to go L equals 75 degrees out of 360. 360 would be the whole circle. 2 stays 2, pi stays pi. And then when you look at the picture, what's the radius? 4. All right, now you're going to have to grab your calculators. There's no way around this. And you're going to type in this equation. Now, one piece of advice is you might, depending on your calculator, you might have to go parenthesis, 75 divided by 360, close the parenthesis, and then times 2 times pi times 4. So type that in, and if you're typing it in the right way, you should get 5.24. So go ahead, practice typing that in. That's important. Okay, let's try part B. Let's find the length of arc. And remember, up at the top, we're finding arc ZY still. So we're finding this arc down here. There's arc ZY. All right, here we go. So our formula is going to go L equals, and then here it is over here. So x over 360. What do you think we put in for the x? 130. So it's 130 out of 360 times 2 times pi. And now what's the radius? Well, this 10 goes all the way across. So the radius is going to be half of that. The radius is going to be 5. When you type this in your calculator, you're probably going to have to put parentheses around 130 divided by 360. So go ahead, grab your calculator, type in parenthesis 130 divided by 360. Close the parenthesis. Times 2 times pi times 5. And if you typed it in the right way, you should have gotten 11.34 centimeters. Great. Will you pause the video and try number 2? And when you're done, unpause the video. All right, so for number 2, hopefully you did this. We're looking for the arc length of AB. That's over here. So we're going to use the 80 for our x. So I did 80 out of 360 times 2 times pi, and then the radius, see how 14 goes all the way across? So the radius is half of that, so 7. Type it in your calculator, and when you do so, you should get 9.77. So the length of the arc is 9.77 meters. Okay, let's try another one. Will you guys pause the video and try number 3, and then when you're done, unpause the video. So you should do, for arc DA, you're going to do 40 out of 360 times 2 times pi times, and it looks like 4.5 is the radius, so times 4.5. So then type that in your calculator, and I got 3.14159264. Hey, that's pi, but that's a coincidence. So we have 3.14 centimeters. So I really like this last problem. It's a word problem, and it's about a throwing ring. Have you ever seen the shot put or the discus or the javelin thrown in a track meet, maybe in the Olympics? Well, according to the Minnesota State High School League, the central angle opening up to the toe board of the shot put and discus throwing ring is 40 degrees. And the radius of the circle is 4 feet long. What is the length of the toe board? So you guys, this white board right here, that is the toe board, okay? And when a thrower steps into the ring, what happens is they step in from the back side and they spin around or they do a glide and they throw the shot put, and the shot put lands out there in the sector somewhere. But this toe board, they cannot step over. If they step over that toe board into that sand, it's a scratch, and their throw will not be measured. And so every throwing rink has a toe board. And our job right now is to figure out, according to this problem, what is the length of the toe board. Well, that toe board is an arc. So we're going to use our formula for length of an arc, x over 360 to pi r. Well, it tells us this angle is 40. So our formula should go 40 out of 360 times 2 times pi, and then does it tell us the radius? Well, if you go back and read up here, it does say the radius of the circle is 4 feet. So 4 goes in for r. All right, let's type it in, you guys. So 40 divided by 360 times 2 times pi times 4. And I got 2.79, and I'm rounding that off, and that would be feet. And so that toe board is a little less than 3 feet long in this case. Will you please try Unit 7, Practice 3? If you have questions, just ask. Have a great day.